Hello again, everybody. This is section 3.5 and 6, the examples. Here's the homework assignment. Eventually, I'm going to have to move that to get to the board over there. So we're going to do, I think I have 8 problems prepared. Whether or not we get that many, I don't know. But one thing about these particular problems is it takes longer to actually write them down than it does to do them. That's why I have them all, I have the first 3 examples. This one, by the way, I'm going to get pretty low. So here we go. This is the first 3 examples, just synthetic division. How to divide a polynomial by another. So I'm going to take this polynomial, 3x cubed minus 2x squared plus x minus 4, and divide it by x plus 3, and it's called synthetic division. So that's minus 3. I don't have to write the x's down. All I need is the coefficients. And there's this mantra: bring down, multiply, add. Bring down, multiply, add. And I say that over and over again. So we bring the 3 down, we multiply, and then we add. And we multiply, and we add. And we multiply, that's 102, right? Negative 102. And we add. And there we go. I just divided one by the other. By the way, the remainder theorem is going to say that x equals negative 3 and y equals negative 106 is a point on the polynomial function. Second one, it's just how to. I want to divide 1, x minus 1, the factor x minus 1, into this polynomial. And the reason this example is because that right there. You need a 0 because there's no cube. You understand? The zeros are at the square, at the fourth and the third and the first degree. You need them for synthetic division. So bring down, multiply, add, multiply, add, multiply, add, multiply, add. There you go. That's that one. And what we're saying, by the way, that the point 1,5 is on that particular polynomial. It's a point on the graph. And so I have this one, and I'm going to move the homework. That's the homework. It's on Noodle, of course. Assignment. And because it's a fraction. If 2x plus 1 is a factor, then x is negative 1/2. That's what I'm doing. And I'm synthetically dividing 4, negative 2, negative 4, 4, 3. Oh, I missed one. Sorry about that. 4, 3. Oh, there's a 0 there. 1, 2. Please understand the example. Where that comes from: 4, negative 2, Zippo because there's no squared term. Negative 4, 2. Okay, so now bring down, multiply, add. Bring down, multiply, that's negative 2, add, negative 4. Multiply is 2, add is 2. Multiply, negative 1, negative 4, negative 1 is, let's say, negative 5. Multiply, 5 halves. Add 2 plus 5 adds 4 is 9 halves. There you go. We're just doing synthetic division. That's how to. That was the first section, actually. That was section 3.5. It's just how to do this. Now, the whole section 3.6 is very theoretical. And here we go. Bear with me as the examples. Writing the examples is hard. It's hard as heck. Okay, so here's the factor theorem. And the page, I'm doing page 276, number 12. I have maybe 3 or 4 more examples. These are all like your homework problem. So here we go, the factor theorem. 3x cubed plus 4x squared. Minus 8x plus 2. That's f at x, apparently. And then, oh yeah, this is right. You show that oops, I'm in the wrong place. Determine f at 3. So, you know, you can put a 3 in there, of course. But all we have to do is synthetic division. Please understand, you're going to be doing this a lot. And it's really a nice procedure. Bring down, multiply, add, multiply, add, multiply, add. 95, sorry about that. Now what we're saying is 395 is a point on the graph, the remainder theorem. Okay, list all the possibilities. I would like to do, no, let's go back to that. Excuse me. There's a lot of theorems right now that some of which we're getting to, some of which we're not. We're not taking this into too much depth. There's a whole science called abstract algebra which does all this, but there's a way just to list all possible roots. Zeros, I'm sorry, that should be zeros, of a function. And this is what's called the rational root theorem. 3, 5, negative 5, 4, 3x cubed plus 5x minus 5x plus 4. All I want to do is list the roots, because we have this whole beautiful tool called synthetic division, but where do you start? Why do you choose that? You know, so far we've been telling you, oh, well, try that. But here you go. We're talking about, there's a theorem called the rational root theorem, and possible roots are factors of 4, I'm sorry, divided by factors of 3. So all I'm doing right now is making a list. We're not going to pursue this thing any further. But, so the possible roots are, let's see, factors of 4. 4, 2, 1 over factors of 3. Moreover, 4, 2, 1 over the factors of 3 are 3 and 1. The factors of 4 are 4, 2, and 1. So, and we have 2 of them, by the way. This is, so the factors are plus and minus. 4/3, 2/3, 1/3, 4, 2, and 1. They're the only possible factors. Now, there's a bunch of other theorems to say, well, which one of these are we going to choose for synthetic division? And that's a good question. We're not actually going to get that far into, we're not going that deeply. Just Descartes' rule of signs is one thing. And so is the conjugate. Yeah, but okay, I think there's only, here we go. Now, the hardest part now is for me to write the example. Because I'm just going to say define zeros. Find zeros. And, zeros. And this is page 276. I think I got number 19 there, whatever, I don't know. 1, 3, 4, 12. X cubed plus 3x squared plus 4x plus. Everything's a plus. By the way, I know right now that everything's a plus that has characteristics. Yeah, everything is a plus. And divided by x plus 3. So, and we want to find the roots. They're telling us that's a root. So I want to go to negative 3. 1, 3, 4. Oh, you should just factor that. When we talked about factoring last section, just factor this, but whatever, let's keep going. There's a 1 there, negative 3, add, multiply, zippo, add, negative 12, zippo. Okay, so what we're saying is x plus 3 is a factor. And actually you can multiply it by x squared plus 4 is also a factor. You keep going. I mean, this is for further reference, but x equals 3, or negative 3 rather, and plus and minus 2i. Right there's a plus and minus 2i. The problem didn't ask you to go that far, but why not? Where are we? Oh, 10. One more. I don't know, one more example. Find all the roots of number 16 on 276. How about this? Three, 1, minus 20, 12. Plus 12. I'm not sure. I have to look. Excuse me. 3, 1, minus 20 plus 12. And then just check out, divide it by x plus 3. So we're taking negative 3. We're telling you that's a factor. Ultimately, you have to decide yourself what the factors are. But we're telling you it's a factor. So all we're going to do is synthetic division. 1, negative 20, 12. Bring down, multiply, add, multiply, add, multiply, add. Zippo. It's definitely a factor because of that 0. And here's the other. So x plus 3 is a factor. This is squared now. Minus 8x, sorry about that. Plus 4. And that equals 0. Hey, you can factor that. Go ahead. Either use that in the quadratic formula, but that could be, you could solve that. I'm doing one more example. I know we're into 11 minutes right now, but one more. Because the ultimate thing is just find the zeros. I mean, it's like when we're doing polynomial functions. I said, you know, analyze the thing from start to finish. That's what you want to do, is you find the zeros. And so number 29, on whatever page, 276 apparently, 2x cubed. Oh, come on, Brad. 2 minus 3 minus 1 plus 1. Hang on. 2 minus 3 minus 1 plus 1. 2 minus 3 minus 1 plus 1. Okay, that's the function. And it says determine the zeros. And it doesn't say, you know, where do you start? You know, how do you start? I don't know how to start. You do, there's a whole bunch of things. One is the rational root theorem. The only possibilities of this are 1 over 2, 1 over 1, and that's plus and minus. And you can check out a 1, by the way, just by putting in an adding or a negative 1. You change the... but let's do a half. And this is because, this is the hard part of what we're talking about. How do you choose that? Well, I'm experienced. There's a theorem called the bounds theorem. There's a theorem called the Descartes rule of sign. But 2, negative 3, negative 1, 1. So now we bring down, multiply, add, multiply, add, multiply, add. So this is 2x minus 1 times 2x squared minus 2x minus 2. And if you want to find the zeros, there you go. Quadratic formula. You know, that's where we are. Good luck. I hope this is helpful.